September 9th, 2024. So, this video is a discussion with Nick from the Rooted Leaf, and I met Nick through Eagle Gardens channel. I'll throw a link for Eagle Gardens channel below, where we were talking about organic cannabis cultivation. And so since then, Nick and I have been friends on Instagram, and we've talked back and forth and commented on each other's videos and posts and such. And I was talking with him last week a little bit about some deficiencies and issues here, and he actually offered to send some of his products to me to try. So and then not really being familiar with him, I kind of wanted to talk to him briefly about how to use them and how to apply them, and have a little more background on them. And so he agreed to come on and share that with all of us. So this conversation is Nick and I talking about his products and how they work. And this evening, right after I got off with Nick, I went out and put down a foliar feed on some of my plants. And we'll track the progress outside on those. And we'll also, as we go into the grow lab here for the fall, winter grow season, I'll be using his products in the grow lab, and we'll track the progress in there and the plant responses. And Nick has agreed to come back and check in with us every week or two and have another discussion about it. So that's really exciting to have an ongoing discussion, and that way we can learn as we experience and reflect and look forward and make plans and see if our plans will work out. And when they don't, we can talk about maybe why they didn't work out. So I think that's a really awesome opportunity. Well, I know it's an awesome opportunity for me, but I feel really privileged that Nick is willing to share it with us here on my YouTube channel so that everyone can learn from it. So I hope you find this discussion interesting or informative. If you do, please like and share. And if you're not subscribed, please do subscribe if that's your thing. And I hope you'll go over and check out Nick's channel at The Rooted Leaf here on YouTube, and also check out his website. And I'll share links below, and you'll see in this video, you'll see a few clips of those sites and such. He's also on Instagram at The Rooted Leaf. So without further ado, let's get started. All right, so we've got Nick from The Rooted Leaf here with us today, and Nick sent me an awesome package of free sample of his products to try. And Nick is all about permaculture and regenerative ag and all that kind of stuff, and he's a wealth of knowledge. So for starters, I'm just going to go pull the stuff up, and I'll let him go over the basics of the products with us. But as this goes on, we're going to get together over time, and obviously the outdoor growing season is ending, but we have the indoor lab, and I'll start applying these products to the indoor lab stuff. And so Nick and I will check back in every once a week or every couple weeks, and we'll talk about the progress, and we'll go into some of the finer details, which will help kind of provide some insight on how these things work in a real growing system. So
should be a lot of fun. It'll be fun to test it out on a variety of different plants and see if there's maybe some responses that we'll be able to predictably say happen across whatever plant you're growing, and then we'll also have a chance to see how each species reacts a little bit different. So it'll be fun.
Yeah, and I've found that to be a fun observation with anything, like to see how each plant reacts to different treatments or nutrients or whatever. Yeah. So the first one I'm pulling up here is the Lush Green. I hope that comes on camera okay.
It does. It's a little bit of that green screen effect. I actually kind of saw the background there. That's pretty cool, though. I liked it. Yeah, Lush Green. There we go. That actually looks pretty cool.
That does look cool. So I assume this is like a vegetative grow type formula?
Mm-hmm. Yeah, so it's a amino acid supplement. It's a pure nitrogen fertilizer. And the idea basically with the product line is that it's laid out where, we've got primer A and B, which are the base nutrients. Those contain all the NPK, macro and micronutrients that, cannabis plants need to grow across their full lifespan, and other plants too, for sure. We find really good results with hydroponic lettuce production, any kind of green leafy vegetables. They seem to do really well with that. Having said that, the formulations for primer A and B, they have enough nitrogen inside of there, but I know a lot of growers like to supplement additional nitrogen sources, or they're just sometimes looking for a pure amino acid based product. And so it's nice to have an option that you can do foliar sprays with. That product in particular has a little bit of free organic acids inside of it, and so it actually participates directly in additional chelation and complex in chemistry. So when you water it into the soil, or even if you just work it into a spray tank with a couple of other products, maybe there's a calcium source or a magnesium or a potassium source, if those aren't fully chelated or complexed, that additional pool of organic acids in Lush Green will kind of help bind them and turn them into something that's a little bit more biologically relevant. It's a really good nitrogen supplement. Like I said, it's pure amino acids, and then we have some fermented plant extracts in there as well. The sage really comes through in that, and I feel like that it contributes a pretty significant amount to the concentration of free organic acids that are in there. But sage has some really kind of unique organic acids inside of it that we're finding is very helpful when used, in conjunction with the amino acids.
Interesting, very interesting.
Yeah, and there's also some aloe inside there. We do about, I think the equivalent is somewhere around 1.5 pounds of fresh aloe fillet per gallon equivalent of Solar Rain, or I'm sorry, of Lush Green. We're not on Solar Rain quite yet, Lush Green.
So that should provide a little bit of silica too, as well, then, right? I would think, or am I wrong?
No, there's no real silicon in there. The aloe vera is just the inner fillet, so it's just primarily
Oh, just
the sugar fraction, the aloe verose
okay.
kind of sugar fraction. It's very particular molecular weight that goes into it, but it's a very biologically active fraction of those sugars. But there's none of that exterior latex or the peel of the actual aloe. We actually did initially when we were screening for different types of aloe. One of them was actually a whole aloe that had the exterior of the leaf still intact, and so we would be able to extract it a little bit more. But we find really good results, like a high amount of biological activity from this particular fraction of the aloe sugars specifically. So on young plants, it can help stimulate rooting. I think a lot of people know that. From other plants, it can kind of help get the fire going again, so to speak, so that after you take cuts or after you prune the moms back a little bit, they tend to grow the shoots back out really vigorously, but they don't get really long node spacing. That node spacing stays very tight. And then for those growers that are out there trying to actually physically shape the moms and train them so that they lay out flat and maybe have a large number of apical meristems coming up, and they use that to take cuts off of. Aloe vera does help kind of promote that a lot. It's like very uniform structure across the whole top of the canopy. They won't just shoot up with no rhyme or reason. So it's a good
That's
product.
awesome. I'm looking forward to playing with that. That'll be a nice tool for re-vegging and that kind of stuff.
Yeah, and it's a unique product because you can pour Lush Green directly. You can take the concentrate and pour it into any other product we make except for Silica Skin, and there's no adverse reaction. Even if you took Lush Green and poured it directly into Calmag or Primer A, Primer B, there's no adverse reactions. This actually kind of helps chelate it even further and complex it even further.
Awesome.
Yeah, it's interesting. So it's very synergistic, not only with our product line and the rest of our products, but also with a lot of other product lines. So if you want to kind of mix and match, it's a good product to use for nitrogen supplementation for sure.
Awesome. Yeah, that's so rare with a vegetative product to be able to mix it directly with anything else and not have it just screw up the balance of things.
Mm-hmm.
Very cool. So let's see. The next one I found here in the box is Calmag Fuel.
Mm-hmm. Yeah, Calmag Fuel. It's a calcium and magnesium supplement. It's kind of unique because it doesn't have any nitrates inside of it. I think we're one of the only manufacturers, certainly one of the very first, to be able to make a pure organic acid form of calcium and magnesium with no additional nitrates. There's no phosphates inside of there, no sulfates, no carbonates, there's no chlorides, there's no animal byproducts. So it's just really low molecular weight organic acid fractions of calcium and magnesium. And a lot of the organic acid profile itself comes from a lot of the plants that we work with. you'll see on the bottle on the Powered by Plant stamp, it's derived from fermented orange peel. And orange peel, as I like to think about, is really thick cell walls. It makes a lot of sense if you think about them as highly specialized structures that are really thick cell walls. And what we're doing is repurposing some of those pectic acid residues and some of the other complex cell constituents that are present inside of the orange peel. And we're kind of extracting them and working them to a level where they can be used to chelate and complex the calcium again. So we're basically making building blocks that contain calcium that are specifically for cell walls. And there's a turnaround time typically, like if you feed your plants a generic source of calcium, like calcium nitrate, for example, there's a turnaround time associated between the plant actually taking it up and processing it and then being able to use that calcium as a cell wall constituent. And that primarily revolves around pectic acid biosynthesis. And there's a couple of convergent points that, the plant's metabolism has to kind of like line up to different pathways, so to speak, so that it can dedicate the flow of energy towards producing those cell wall constituents. So what we find is that turnaround time is reduced. It's reduced significantly. It's pretty much eliminated altogether because there's no need to process it any further. It's already ready to go to become a new cell wall. And so the response from plants is actually remarkably fast. It happens within a couple of minutes. The plants will start responding to it. So whether you do foliar sprays or a root drench and a soil application, the plants respond very quickly to it.
Wow, I got some cannabis plants outside. I can't wait to put some of this down on them because they need a little help in the Calmag department, and I've been holding off for this. So
yeah. And what we're finding, outside of cannabis, for crops that are sensitive, like fruiting plants, apples, cherries, any kind of fruit like that, even tomatoes, they need a constant supply of calcium going to the fruits during that fruit formation stage. And the reason specifically is that fruits themselves are not major sites of transpiration, whereas the leaves are. And calcium is always going to follow the transpiration stream. So what we end up with when we're using generic forms of calcium is that most of the calcium gets sunk into the leaves, and the fruits oftentimes struggle to actually accumulate enough calcium. So they end up with a variety of physiological disorders and diseases. In some cases, it could be cracking on the exterior of the fruit. It could be a hollow pit on the interior of the fruit. It could be a little bit bitter. The flesh itself could not form properly. And these are all things that dictate the price points of these fruits. So if you're growing apples, for example, and you have really premium, high quality apples, you'll definitely be able to get top dollar for it. But if your fruit has cracked exterior, or if it's got hollow pit or bitter pit, it'll automatically be screened and put into a lower price category. And so for farmers, it makes a lot of sense to be able to use a product like Calmag Fuel, like the one that we make, and it has this ability to help reverse blossom end rot and reverse bitter pit. And it's because the solubility of that calcium is so high that the plants can actually divert a significant concentration over to the fruits. Again, the fruits don't transpire, very, very low transpiration potential. And so plants can sometimes struggle to load the appropriate amount of minerals into there. But with Calmag Fuel, because the chelate itself is so soluble, you can fit a very large amount of calcium in very tiny drops of water. And then it's also very low molecular weight, which means that it's freely soluble across cell walls and cell membranes and things like that. We're not dealing with very complex and long chain forms. We're dealing with forms that are so small that they just readily flow and pass right through, things like the one-way check valves that you were talking about in reference to potassium. So it's a nice little, and we've actually tested the theory out. There's a couple of videos on our Instagram page about it. We had a grower, Jordan from Growcast, and he was growing some tomatoes, and they were starting to experience. He actually did this intentionally. He grew some tomatoes and totally cut the calcium out, and he started to notice blossom end rot was forming because there wasn't enough calcium being sunk in. And then he started adding Calmag Fuel, and he noticed that the fruit actually grew right past that, and it was able to heal the necrotic spot. And so as it continued to swell and grow, it actually was able to kind of correct the scar tissue, so to speak, that forms when you have this permanent damage caused as a result of not having enough calcium. So it was really interesting to see that.
Wow, yeah, I've never seen that. And I've worked with some products that are pretty well chelated, but wow, I've never seen it like reverse back out of it. That's awesome. Yeah. Another one I can't wait to play with. These are all these products are all going to be a lot of fun to work with.
Yeah, and that's a really special fraction of organic acids that are present inside of Calmag Fuel. aside from the orange peel and the stevia and the other plants that we use, the acetate fraction and the citrate fraction that we're working with, these are among the most abundant metabolites that are produced in all of nature. All plants produce acetic acid or acetates, and all plants produce citrates. It's actually a primary function of the mitochondria inside of plant cells. Anyways, one of their main jobs is to produce citrate or citric acid. It's actually called the citric acid cycle.
Right. Okay.
It's referred to as the Krebs cycle, or you may have seen TCA for tricarboxylic acid.
Yep.
Just a fancy way of saying it, the citric acid, because technically citric acid is tricarboxylic, acetic acid is a dicarboxylic acid, and then there's organic acids that are monocarboxylic. I'm sorry. I think acetic may actually be monocarboxylic. I'm gonna have to double check that. But at any rate, there's mono, di, and tricarboxylic acids. There's probably more complex organic acids as well. But the point is basically, if you find the right profile of organic acids and you plug them into your plants through the feed water or through foliar sprays, when they take those organic acids up, they can turbocharge the processes that are naturally going inside of those plants anyways. When you put citrate chelates as foliar sprays on your plants, you bet the mitochondria are going to respond to it inside of plants. And so there's a correct way to stimulate that kind of growth in the plants. And I think that's further enhanced when you add the correct types of minerals. In this case, it's calcium and magnesium with those specific fractions of the organic acids.
Very cool. Yeah, I know. Excuse me. I know with humans, same kind of thing. There's a lot of diseases are based on actually like lack of mitochondrial function, and it comes down to like certain missing key elements. And once you get that going, it turns the energy on for the whole system. So that makes a lot of sense.
Mm-hmm.
So the next one is Resin Bloom.
You should smell that one. You should shake it up and pop it open and smell it. It's impressive. Yeah, that one, it smells really, really good.
Yeah, I'm looking forward to smelling all of these actually.
Yeah, that one's always been a customer favorite.
Yeah, that smells familiar.
Yeah, so it's got fermented jasmine and fermented ginkgo in there. The jasmine flowers we start with whole ones. I posted a video on our Instagram actually maybe a couple of weeks ago about it. They're really hard to find, the whole jasmine flowers. It's a lot easier to find, particularly for agriculture. It's like no one else is using whole jasmine flowers. I think we're the only manufacturing company that is doing that. It's a lot easier to just go on Alibaba and buy like methyl salicylate or methyl jasmonate, or some kind of jasmonic acid derivative that's been stabilized.
Yeah.
But there's a benefit with working with whole jasmine flowers, and Resin Bloom has always been one of our best-selling products because it's so apparent the effects that it has. Along the same lines as what we were just talking about with Calmag Fuel, there's a profile of organic acids, and in Resin Bloom, it's a little bit different. It has the acetic, it has potassium acetate, it's got potassium citrate. There's also a potassium fulvate, like a fulvic acid fraction that we're making ourselves. And all three of those are in a particular ratio to each other. And what we find is that the particular ratio actually encourages better terpene synthase activity. So the enzymes themselves become upregulated because they have more substrates flowing into them, and they can produce more terpenes, they can produce more cannabinoids, or the cannabinoid synthase enzymes can produce more cannabinoids, and the terpene synthase enzymes can produce more terpenes. And so it just really upregulates and provides building blocks for terpenes to be made. And the cool thing about that is because it's a pure potassium product that has highly soluble forms of potassium, it stays really mobile inside of the plants. And so if you're using that product maybe in the last couple of weeks of the plant's life, it doesn't accumulate inside of the plant tissue at all. It stays in a really mobile and readily soluble form. So you don't have to worry about things building up. We've actually seen better results with people, going through the flush period, instead of using just plain water, adding a little bit of potassium. I like the analogy of a marathon runner and why electrolytes are important for marathon runners. It just seems to make a lot of sense. You can't just pound water when you're running a marathon. Like at a certain point, you need electrolytes so you can actually, conduct the charge properly and transfer elements in and out of your cells. Plants are exactly the same way. They need potassium, high concentrations, in order to be able to properly exchange all of the things that are happening inside of them. If they've got a nutrient-rich environment inside of them with a variety of different elements, some have different charges than others. some are bigger, some are smaller. And so plants have to establish an equilibrium between how all of those are getting processed. And a good way to do that is to keep the potassium level very high, because then the plants will naturally go through their senescence process a lot more readily. And they actually do end up being a lot cleaner overall. They end up flushing themselves out a lot better, just like a marathon runner who's got potassium inside of their bloodstream. When they cross the finish line and they just finished that marathon, they're not going to feel like they're about to crash or their heart's about to explode, because they have enough electrolytes to be able to hold that charge and to be able to balance out all the metabolic activities that are happening on a cellular level. Plants are no different. They're exactly the same.
Yeah, yeah. I mean, at the end of the day, it's all charge exchange, right? Like, so you got to be able to transfer that energy.
Yeah, and balance it out. I mean, potassium is the most abundant cation inside of plant cells. They take up huge concentrate. Every plant does this, particularly green leafy vegetables. I mean, I remember doing a research project maybe a couple of years ago, and we didn't fully understand this at the time, but we ended up feeding the lettuce plants like 500 or 600 ppms of just potassium, nothing else, just potassium. And these were small, these are small plants. They're made to be harvested in about 30 days. It's literally just a head of lettuce that goes towards, making a sandwich or a salad or something like that. And what we found was that the amount of potassium that the plants are capable of taking up is almost infinite. I mean, you can feed so much potassium that it starts to become really expensive. You're kind of thinking like, I can't afford to feed them this much potassium, but the plants are capable of taking it up. And like you just said, along the lines of the charge balance thing, potassium is a monovalent cation, which is a really useful property to have when the plants are also producing a lot of negatively charged compounds like organic acids through their normal metabolic processes. And these organic acids have a negative charge associated with them. And the positive charge of potassium can kind of help compensate to create that charge balance. And this is huge in terms of the carbon flux that's going through the plant. So plants are taking in carbon in the form of CO2 and they're metabolizing that, and they're stockpiling. In reality, they're building up these pools of organic acids, and the organic acids can be properly kept in place if there's enough potassium inside of the plant. So what we find is, if you want to feed high amounts of carbon to your plants, you really need to feed a connected amount of potassium that's associated with that. And if you want to put more CO2 on your plants, you're going to need more potassium. If you want more soluble forms of carbon like organic acids circulating within the plant tissue at any given time, you need high concentrations of potassium present inside the plant at all times.
That's good to know. I wasn't aware of those nuances. Thank you.
Yeah, and it also has a lot to do with the transpiration stream. Potassium, I think, probably more so than any other element, potassium plays a critical role in the hydration status, not only on a cellular level, but also on an organism level. So the whole, how wet is the plant? How much water is it capable of taking up, and how far can that water travel before it gets diverted for some reason or other. You want the water pump, so to speak, in the plants to be active, because the amount of water that the plants drink through on a daily basis is going to be directly correlated with their productivity. If you have plants that are only being watered once a week and they're growing in some shade and it's not that intense of a grow environment for them, you're never going to win cups or awards. You're never going to win first place uh, with anything from roses or cannabis or even fruiting crops and vegetables. Like, they need direct light in most cases. They need high intensity light, and they need high concentrations of potassium in order to actually make all the stuff happen properly.
Yeah, yeah. I mean, that photosynthesis drives the whole process. And I think, correct me if I'm wrong, but I think potassium also carries all the other nutrients into the fruits and flowers of the plant as well, right? That's also part of the transport, isn't it? Or do I
And
have?
I would say the caveat there would be that the flow of water, which is dictated by potassium, could be one of the effects that you're talking about there. As far as like a direct interaction between potassium as an element and certain other compounds that might be present, it's maybe a little bit more disconnected, I guess you could say. But it certainly does play an important role, particularly in the accumulation of, like when we're talking about wine grapes, for example. As the fruit starts to form and set, they really can swell up, so to speak, with potassium. So as the grape starts off very small and then it starts growing, there's a huge amount of potassium that can be sunk inside of there. But it's not just elemental potassium. It's not just that it's potassium in a particular form, like an organic acid form. And when that when that gets worked into the actual fruit and you pick the fruit, you can eat it and it might taste a little sour because of the organic acids, or you can use that for fermentation chemistry, depending on what the specific ratio or profile is of the fermentable sugars with the rest of the profile. Maybe there's a lot of anthocyanins that are present. Maybe there's tannins. There's more complex organic molecules present, and all of them, generally speaking, they have the ability to interact with potassium. But more specifically, along the lines of what you're talking about, it's like this dual effect where the effect that potassium has on the water flow throughout the whole plant gives rise to some of the effects that you're talking about, and then also the direct interaction that potassium has with some of these substrates or precursors or building blocks allows it to then get sunk into the fruit, accumulated in high concentrations, and then not only do you end up with a lot of potassium inside of the fruit, but you've also got things like the phenolic compounds that are useful for making grapes or fermentable sugars and organic acids, things like that.
Okay, interesting. So Peak Bloom is the next one?
It's another one that's worth smelling. That has the fermented artichoke extract inside of it, and it's really earthy, but it's extremely sweet. It almost smells like dates or figs. Remarkably sweet. Like you can smell it. If you do a foliar spray of that, you can smell it.
Oh,
through
yeah.
the whole garden. Yeah.
Yeah, it does have a nice sweet smell to it.
Yeah. Yeah. And it's not very typical that you would smell a PK booster like that and be like, oh, wow, that smells really good.
No, usually it's either inert smelling or horrible. Oh, did you freeze? Did I freeze?
Oh, did I lose you there? Guy froze. Yeah, it's me.
Yeah, okay.
Yeah, it's his unstable network connection.
Okay, I think we're back.
Cool. Well, that's good. We were just kind of transitioning between talking about products, so it's a nice time for the internet to just temporarily cut out.
Yeah.
Yeah, Peak Bloom, the idea behind Peak Bloom when we first started formulating it was how do we get phosphorus in a form that is as close to being 100% bioavailable for plants to take up as possible? Because the major problem with phosphorus fertilizers is that a lot of it, if applied to the ground, just gets bound up and it becomes unavailable for plants to take up, and it just doesn't do any good. And so a lot of fertilizer manufacturers that make PK boosts like the monopotassium phosphates and the monoammonium phosphates and dipotassium phosphates, so on and so forth. Well, monoammonium phosphate isn't technically a PK booster, but it's used in PK booster formulations for sure. You can get like a 1261-0 or you can get an 1152-0 grade, which is a huge astronomical amount of phosphorus. They'll cut a little bit of that in with some of the other like monopotassium phosphates, which is like a 05234. Also a crazy amount of phosphorus present there. And then they go ahead and tell you to use it at an equivalent rate of like 1,000 ppms or something like that. And it's like, whoa, that is way too much for the plants, And I've seen high numbers. Like I've seen commercial cannabis cultivation facilities, very large scale, mind you, like 30,000 square feet of actual canopy space. They're feeding about 700 to 750 ppms of elemental phosphorus to the plants, which is just this astronomical amount.
Wow.
Yeah, and as I'm sure and maybe this is more for your audience, but the correct dosage of potassium is close to 30 to 50 ppms of elemental phosphorus that the plants actually need. So compare that to about 1,000 ppms that sometimes the fertilizer manufacturers would recommend. The thing that you got to factor in is that if 75 to 90% of that 1,000 ppm becomes unavailable for plants, then in reality they're maybe getting 100 ppms on the high end if you feed them 1,000. And if you're feeding them somewhere around 700, you're maybe getting about 70 ppms. So that kind of puts things back into the high end of the sweet spot. So when we were doing the formulation work for Peak Bloom, the goal for us was to make a form of phosphorus that was rapidly taken up and resisted tie-up in the soils very well. So you could have a soluble cation-rich profile, like a lot of calcium present in dissolved form in the feed water, a lot of potassium, a lot of magnesium, and they would not have any interactions with the phosphorus. And ultimately what we came to the realization of was that sugars, complex sugars, fructooligosaccharides that we're extracting from artichoke, go a very long way in complexing the phosphorus and interacting with it in a way where it just tends to make it stay more available, more rapidly taken up by the plants. It participates more directly in the plant's primary metabolic pathways, because a large portion of what phosphorus is used for in the plants is going to be energy production anyways. Phosphorus in the form of a sugar phosphate actually accepts CO2 out of the air. So in order to have proper carbon metabolism happening in the plants, you need adequate levels of phosphorus. And if your plants are deficient in phosphorus and you have a CO2 meter inside of the room, one of the things that's a telltale sign is if the CO2 meter continues to read a very constant amount and the tank itself isn't draining, and you think to yourself, well, the CO2 is in the air, why isn't it going inside of the plants? And then you might further look at the plants and kind of look at the morphology and determine if they have a phosphorus deficiency. Sometimes there's visual cues, visual signals, like the stems become really purple, they become very brittle, and they become very rigid, so they are not capable of bending before they actually snap and break. That, if you saw that on your plants in conjunction with you have the CO2 meter and you're noticing like the tank staying full and the CO2 concentration in the air is roughly the same, it could be a sign that there's a phosphorus deficiency. And when you apply phosphorus to the plants and correct that deficiency, one of the first things that's one of the first bottlenecks that's removed is the bottleneck for carbon metabolism. So the plants will start to take in the carbon, you'll watch that CO2 level go down, and the tank itself will start to drain, and the plants will produce the sugars that they need, and then they're capable of recycling that phosphate sugar. So it's an important element for sure to be able to have in constant supply without overfeeding or without overdoing it. And it works really well. I mean, we're probably above, I want to say we're somewhere around 90 to 95% bioavailability at minimum. In reality, it's probably closer to about 99%. So you can add Peak Bloom and Calmag Fuel into the same foliar spray tank, and the two don't have any adverse interaction with each other. The two get absorbed. Yeah, they get absorbed. And you can run very, very low amounts because the NPK analysis for Peak Bloom is 0.76. And what that translates to effectively is that 1 milliliter of Peak Bloom is equivalent to roughly 10 ppms of elemental phosphorus. And if you keep in mind in your head that the sweet spot for plants is between 30 and 50, it makes it very easy to figure out how much Peak Bloom you need. It's about 3 to 5 mils per gallon.
Yep.
And if you're doing foliar sprays, if you look at our foliar spray chart, you'll see our recommendation is 2.5 to 5 mils per gallon. So we want to see somewhere around 25 to 50 ppms of phosphorus getting worked onto the plants so that we can correct deficiencies and we can prevent deficiencies from happening. At the same time, we're not overloading the plants. We're not putting so much phosphorus on that we start worrying about salt buildup in the soils, which I think happens with a lot of, particularly a lot of cannabis growers. Sometime between week 3 and 5 of flowering, the plants just start to get really sluggish. They slow down. There's yellowing that happens, and it happens to be right around the time that PK boosters are implemented, and is because all that excess phosphate that is being applied to the plants starts tying up with elements like calcium. And now all of a sudden the plants show signs of calcium deficiencies because you're overfeeding PK boosters, and the two are forming calcium phosphate in the soil, which is what bones are made out of. And bones fossilize in soils. That's kind of how it happens naturally. There's no such thing as a bone meal producing factory that just goes around and sprinkles like micronized bone meal and like dusts it across and evenly throughout the soils. It tends to accumulate, it tends to precipitate out of solution. And as soils go through wet dry cycles, the chemistries that happen when the soil is going through wet dry cycles, the calcium phosphate tends to be excluded from that because it's not soluble in water. And so you have these aggregates or these complexes that form, and they resist being hydrated properly, and they resist participating in the same kinds of chemistries. So they become very difficult for plants to unlock, which is why they show signs of stress, and they may even ultimately show signs of phosphorus deficiency, even though people may be feeding them at insane rates. This type of stuff will not happen with Peak Bloom. And like I mentioned earlier, the goal was how do we get as close to 100% availability as possible? This was an important consideration for us because our product line is extremely heavy in calcium. I think we're actually the heaviest product line out there in the cannabis market, that just in terms of calcium content. In the base nutrients, it's 4.5% calcium that we guarantee. And then Calmag Fuel, separate standalone Calmag product that we have, we guarantee 6% calcium inside of it. So 4.5 plus 6% is a huge, concentration of calcium. And it doesn't tie up with the phosphorus at all. So yeah. It's good stuff.
I'm very glad to see that because so many people are just not even aware of the actual calcium demands that are required for a plant. I mean, it's required for every single cell. It's a huge part of the whole biochemical sequence of nutrition in plants. It's a critical nutrient that people just so often overlook or don't understand. So
Yeah, and it should certainly be considered as a macronutrient, just in terms of how much plants are capable of taking up. Earlier I mentioned that potassium is taken up in the highest concentrations. You can easily fit 500 to 600 ppms of just elemental potassium inside of your plants. And then from there, the next most abundant is going to be magnesium. But we need to take a look at the concentration of magnesium that people are feeding their plants, because it is going to be, in most cases, it's pretty close to the amount of phosphorus that they're feeding. If you're feeding about 30 to 50 ppms of phosphorus to the plants, chances are you're also going to be feeding about the same magnesium to your plants. About 30 to 50 is the sweet spot. Calcium can be taken up in excess of 300 ppms, no problem. 100, 200 ppm is kind of like a good place to start. 300 ppms is a pretty hefty dose for them overall. But it's interesting that inside of plants, inside of the cells, we've got this order of abundance that seems to not match what is flowing through the plants in terms of the transpiration, right? When we're mixing up our feed water and we're actually mixing up the nutrients, we feed most potassium, we feed calcium after that is the next most abundant, and then way below that we'll feed magnesium at about a tenth of the rate that we feed calcium. But once that feed water works its way inside of plants, the calcium and magnesium actually get reversed. There's more magnesium kept in a soluble, free form. There's a pool of magnesium that is much larger than the pool of available calcium. And that could be by a factor of, in some cases, it could be by a factor of 10x. So it's really interesting and remarkable to think about how we start off with feed water that has 10x more calcium, but then once it actually works its way inside of the plant, we'll end up with 10x more magnesium than calcium. I hope I said that right. Did I say 10x more calcium than magnesium first?
no, I think you said it right.
Okay, cool. I just wanted to make sure. Yeah. So the important thing, the reason that I bring that up is because, I want people to understand that calcium should be considered a macronutrient, because you feed so much of it to your plants and so much goes and gets sunk into things like cell walls and the leaves during the vegetative stage. It becomes a constituent of the roots itself. Major calcium sink is the actual roots themselves, the leaves, the stalks, the stems. None of that stuff is useful though, because we're growing cannabis for its flowers. And so really what we want is to see the calcium accumulate inside of the flowers and inside of the floral tissue. So it's important to keep those calcium levels high in the mid to late stages of bloom as the flowers actually start to grow and mature and develop. And the last thing that we want to do is get that calcium bound up with excess phosphorus, because then the flower development gets stunted too. The cell walls become really thin and weak and brittle, and they become very susceptible to diseases like powdery mildew. And that's ultimately what ends up happening, is the plants could be healthy all through veg because they're getting an adequate amount of calcium. And then they enter the flowering stage, and there's this adverse chemistry that's happening in the soil between the phosphorus and the calcium. And 5, 6, maybe 7 weeks in, the plants eventually, that stress catches up to them, because they've formed flowers that are deficient in calcium, and they are susceptible to attack by powdery mildew. And that's why, right towards the end of bloom is almost, all cases, that's where people start to get disease pressures.
That's where the crash always shows up, isn't it?
It is, and it's a reflection, in my opinion, of a calcium deficiency. So the whole cannabis industry, in my opinion, is chronically deficient in calcium, because no one's understanding that it really is a macronutrient, just in terms of how much can be taken up. It could actually, your plants can take up more calcium than nitrogen across their full lifespan. Just to give things, because people focus on nitrogen as like the yield element, or like that's the one to focus on.
Going to say, so many people focus on nitrogen, but calcium is equally, if not more important.
Yeah, and the problem, sometimes between calcium and nitrogen is that most of the Calmag products out there on the market, they're nitrate-based Calmag. So, growers will look at the nitrate and want to chop that number out because they don't want excess nitrates in mid to late stages of bloom. But they automatically take a hit on the level of calcium that the plants are getting, because they chop out the calcium nitrate. So it's nice to have products that you can turn those things independently of each other. We got the Calmag that has no nitrogen inside of it at all. We could have made an amino acid chelate, but we decided it's best to not. And then Lush Green, being the amino acid product, you can kind of you have the ability as an advanced grower to fine tune the exact NPK ratios that your plants need.
Yeah, you can put them together when you want to and run them separate when you don't, which is actually a really nice fine tuning tool to have in a nutrient line.
Yeah, and it's so strain specific. Like, we have a lot of customers that are growing like landrace strains that are like, from equatorial regions, 16 to 24 week long flowering cycles. And, we're finding certain trends with those types of gene pools. They really like extra calcium, pretty much all the way through flower, almost basically right up until harvest. And in other cases, they may need a little bit less nitrogen, maybe starting somewhere around halfway through their bloom stage. And then the phosphorus levels, they need like bare minimum. I mean, we'll do like maybe 1 or 2 mils per gallon of peak bloom. And that 10 to 20 ppm of elemental phos is kind of the sweet spot for them. So it's nice to be able to take, landrace genetics, like really, really old gene pools that have not been exposed to modern or conventional fertilizer, and give them exactly what they want without forcing them into a system. And also at the same time have programs available for the more indoor friendly, the hybridized strains that are closer to 8 or 9 week flowering cycles, that have been specifically selected and bred for indoor cultivation. They can still get set up with a fertilizer program that allows the fine-tuned nutrients to be delivered to them.
Yeah, that's awesome, man. That is just awesome. The more we talk, the more excited I am to like go out and put these in play.
Yeah, and it'll be great to hear, what your initial impressions are and what the reactions on the plants were.
Yeah, and I'll be looking forward to our check-ins too and discussing it and fine-tuning my skills as well in the process.
Awesome. Yeah, me too.
So Silica Skin is the next one up here.
Yeah. Silica Skin. That's a really good product too. Oh boy, silica chemistry is very complex. We can get into like a whole rabbit hole here, but the idea basically is that silicon is there's a particular form of silicon. People refer to it as silicic acid, orthosilicic acid, or monosilicic acid. Basically, the way that I like to describe it is that silicic acid is what happens when you have silicon dioxide, SiO2, meet 2 molecules of water. It's the very first form of silicon that is actually truly soluble. Otherwise, you have a suspension. You have a silicon dioxide suspension. There's a different molecular configuration, though, as well. So I want to be clear. It's not like you took, 2 atoms of H2 or 2 molecules of H2O and combined them with 1 molecule of SiO2. There is some reconfiguration that happens. But if you just look at the molecular formula for orthosilicic acid and compare that to 2 molecules of water and 1 molecule of silicon dioxide, you'll find that they're exactly the same number of H's coming from the H2O and Si coming from the SiO2, and then the oxygen obviously coming from both the water and the dioxide form of the silicon. Same number of atoms, different configuration. And so the goal here is to create a kind of a silica product that behaves like a silicic acid, meaning it releases that soluble form of silicon for the plants, but one that also exists and is stable at a high pH, which sounds a little bit counterintuitive because most people think silicic acid has to exist at a low pH. There's a lot of very expensive products out there that cost, in some cases, several $1,000s per gallon. Crazy expensive. And they're just, they're stabilized at a really low pH. They have all kinds of synthetic acids that are used, and the pH of them can be extremely low, like 1.0 or even below 1.0. And the issue with them is that, yes, they're stable in concentrate, but when you add that into your feed water tank, you would never feed your plants at a pH of 1.0 or 0.5 or whatever it is.
You lose stability as soon as you mix it in. You basically lose the stability that you have in that acid form, right?
Yep, exactly. And so there's a clock that's, you're on a timer now. As soon as you take the product outside of its stability range, and stability range is like get it as acidic as possible in order to actually stabilize it. And when you bring that pH up, what ends up happening is that silicic acid is susceptible to oxidation, even if it's just passively, not like an exact chemical attack because you have, an oxidizer that's being introduced, but just the way that the chemistry can kind of happen is such that you can effectively get the silicic acid to be oxidized and that'll start to polymerize it. And maybe there's a couple of other, it's not just the oxidation. The way that silicic acid can polymerize, so you start with the monosilicic acid, and then that will polymerize into polysilicic acids. There's a certain point where you have this linear chain that's being formed, and then eventually what ends up happening is the molecule becomes very big and it doesn't get held in the water anymore, so it starts to form a suspension. And as it forms a suspension, it'll start to drop out. And there's this interesting phenomena that happens where there's this cyclization that happens. There's an actual ring-like structure that's formed where the tail end of one silicic acid monomer that's connected to a larger polymer form of it will kind of revert back and attach itself to the head group, and you have this ring-like aggregate or ring-like structure with it, and that totally falls out. It precipitates out. If that happens in an acidic environment, you can precipitate out a gel-like substance, and if it happens in an alkaline environment, you actually get flakes. You get actual salts, silicate salts. And a lot of growers may have seen this phenomena happen where even if you go in just to unscrew the cap on the bottle and pull it off, if you notice there's some flaky like material on the exterior, that it precipitated out in an alkaline environment. As it dehydrated, it became oxidized. But on the flip side, if you notice like an applesauce like consistency or something a little bit more gelatinous, jelly like material, then those are silicic acid monomers that have polymerized. They can be hydrated again, and that can be reversed a lot more easily. Generally speaking, the silicate salt forms, they're harder to solubilize and they take a little bit longer. But the gelatinous forms, they can just be, you add a little bit of hot water to it, shake it around, and it will kind of redissolve and go right back into solution.
Okay. Yeah, that makes a lot of sense. I have potassium silica that I've been using as a silica source. And yeah, all around the top of the jug, there's, it's building the little rocks of silica, basically.
Yeah. So one of the parent materials for Silica Skin is a potassium silicate, but the complex in chemistry of it, like we use a lot of hibiscus. The hibiscus itself, hibiscus flowers are very rich in organic acids, and there's a very specific and peculiar type of organic acid inside of hibiscus flowers that we find helps stabilize silicic acid at a high pH, which again seems counterintuitive, but it's true that potassium silicate in a high pH is still capable of releasing silicic acid monomers to plants so that they can grow and get that soluble form of silicon. That is 100% true. So yeah, silicic acid can be stable at a high pH. The way that Silica Skin works specifically is to allow that silicic acid to exist in that soluble form and stabilized at a high pH without such a high price tag. I think the MSRP on Silica Skin is one of the best in the market. I want to say it's around $50 for a gallon retail price, and it's guaranteed 4% soluble silicon. So that's the same kind of silicon that you would get from the fancy orthosilicic acid products that have a really low pH. And they may also come with a lower concentration of silicon overall. So yeah, it's a good product.
Yeah, I remember looking at other silicon products or silica products years back, and like all of them were super pricey, and like the percentage of silica in them was not very much. It was like, I mean, I don't know, am I going to get any value out of it at the end of the day?
Yeah, and in nature, just naturally speaking, silicic acid is soluble in water up to maybe about 100 ppms. And this is before we include anything else that might throw that solubility off a little bit. Obviously, if we have cations like calcium, we're going to make calcium silicate, and that will precipitate out. Calcium silicate is the exact same thing that fireproof drywall is made out of. Fireproof drywall, you could stick a garden hose on a sheet of fireproof drywall and water it all day long. You will never get that back out. So calcium silicate, not very bioavailable for plants, but there are technologies out there that people are starting to micronize it and make it such a small particle size that it can be a suspension. But yeah, so silicic acid is going to be roughly soluble up to about 100 ppms in solution. When you start factoring in other elements and other nutrients in feed water, that number goes down a little bit. And so the real question is, how do you create a solution that is capable of feeding enough silicic acid to plants that they don't become deficient, but at the same time without participating in an adverse way with some of the other elements that are present directly surrounding it? And I think this is where some of the plant extracts that we're working with, particularly the hibiscus, there's also safflower inside of Silica Skin. They have these protective effects, so to speak, on the actual silicon molecules themselves, or the silicic acid monomers. It protects them against adverse interactions. So when you mix up your spray tank, if you want to use Silica Skin as a foliar spray, for example, you're mixing it up with some of our other products, that silicon isn't going to interact adversely with other products. So when you're using Silica Skin and the rest of our products, you don't have to worry about things like, which order do I add it in? You can add silica pretty much after any other product. If you're using RO water, we recommend adding it last rather than first. RO water tends to interact with silicon in a way that actually encourages the polymerization. And it has to do with the electronegativity of oxygen. It's just a little bit hungrier than the hydrogen is capable of satisfying that hunger. And so it's always looking to form an additional relationship. So if you have RO water and the first thing that you do is put in silica, that silicon, if there is free silicon that's available in the form of silicic acid, it's going to interact with the oxygen present inside of the water molecule, and you could see some polymerization happen. So it'll start to make a little bit of a gel-like colloid. But that's the only real consideration. You can pretty much, other than that, you can add Silica Skin in whatever order you want. We have most people just adding it last because the feed water at that point is fully buffered and fully complexed. So you add in a little bit of silica and it works just fine. There's no cloudiness that forms. There are rare instances where we'll see that if someone's on well water and they have 300 ppms of calcium carbonate coming out and the pH is super high. There may be a need to kind of treat or adjust or figure out a workaround for that. But in most cases, it's pretty much plug and play. It's a flawless system.
Awesome. Awesome. That's exciting, man. That's super exciting.
Yeah.
So root anchor is the next one.
Another one of our, actually, these are all really good products. They're all customer favorites for one reason or another. Root anchor is a really concentrated mixture of beneficial microbes. There's 12 strains of bacillus inside of there. It also has 9 species of sea plants, and there's a bunch of humic acid. There's a really, really high concentration of humic acid inside of there. So what we're doing is we're extracting the humic acid, and it's a really high quality humic acid source. It's one that's not fully saturated, because the problem with humic acids is that they're all different. There's no two humic acids that are the same. There's not even a formal definition for what is a humic acid. When I'm talking about acetic acid, I can tell you exactly the molecular weight of acetic acid. I can give you a molecular formula, and if that molecular formula is different, it's no longer acetic acid. We're not talking about acetic acid anymore. Same thing with citric acid. Citric acid has a very specific molecular formula, and if it's not that molecular formula, it's not citric acid, it's something else. Humic acids are not defined as such. There's no one formula for what a humic acid is. It's more of a general kind of umbrella term that's used to capture a variety of different properties, and there are various differences in a variety of different humic acid sources depending on what you're getting. So the humic acid source that we're getting is really clean, and it's not fully saturated, which means the active sites of that humic are open for interaction. This is a really useful feature if you want to talk about humic acids and their ability to chelate metals or to complex metals, or to even bind up heavy metals and excess toxins in the soil and render them unavailable for plant take-up. So what we do is we're extracting the humic acids that are rich in these functional groups that are just ready to participate in some kind of chemistry. And then we extract seed plants and get a bunch of really, really complex cell wall constituents. In some cases, they're the actual sugars that are present inside of the kelp, like the sugar kelp that we get, Laminaria digitata, produces a type of sugar called laminarin, and that has known chelation properties with calcium. And what we're doing is we're basically like infusing these sugars directly into the humic acid molecule, so that it serves a biostimulatory kind of a function. It's really good for microbes, really good for fungi, and also really good at just participating in the basic acid-base chemistry and reduction oxidation chemistry, redox chemistry in the soil. So it makes things a lot more available. It keeps the microorganisms very happy. It keeps them thriving. And a lot of the specific extracts a lot of the specific compounds that are being extracted from not only the seed plants, but also the terrestrial plants, as I mentioned, they're really good prebiotic food sources for beneficial microbes and beneficial fungi. So it's a nice synergistic system that we're putting together inside of that bottle. That's the most complex product that we manufacture. It takes anywhere from 3 to 5 days just to manufacture a single batch, and it's the most intensive, labor intensive. It takes the longest, Filtration is a dedicated process just for root anchor because it's such a specialized and unique product that it really does require its own manufacturing equipment. It requires its own process flow. It's kind of like its own animal, so to speak. It kind of lives in its own space, and uh, in order to get that one right, it's very complex.
That must have taken a tremendous amount of work to arrive at a final, product to even develop something like that. It must have taken a lot of.
Yeah. The hardest part with that was to stabilize the strains of bacillus that are in there, because they're beneficial probiotics that are present, but they're not dormant in the bottle. They're actually live and active. So if you crack the lid on it and smell it, you may recognize the smell of some bacillus or lactobacillus or brevibacillus. It's very much so like a fermentation, live and active culture. It almost smells like yogurt. Yeah. And actually, when you smell that, look on top too. Just try to look and see. There should be a nice little like a iridescent kind of an oil slick on the
Yeah.
very top of that. Yeah, so that's fermented cacao. We get this really high quality Peruvian cacao. It's an heirloom varietal. It's grown very high altitude. It's super high fat. It's like 20 to 22% fatty acid.
Cacao, like
Yeah.
cocoa cacao, like.
Yeah. Like cacao powder that's used to make
Yeah.
chocolate. Ours is raw. It's
I
unalkalized.
ate a ton of that stuff, so that's awesome. That's hard to
Nice.
find
Yeah.
in a formula for plants as well. I'm glad
Yeah.
chocolate too. They deserve it.
Nice. Yeah. So this is basically it's a ceremonial grade cacao. Um,
Awesome.
very high quality stuff. Yeah. And it's very, very rich in fatty acids. So when you open up a bottle of root anchor after shaking it and you see what appears to be an oil slick on top, and maybe it has this like kind of like a sheen or an iridescent kind of glow to it, that's most certainly the fermented cacao. It's got this like very rich fatty acid profile. And when was the last time a fertilizer manufacturer said you got to feed fatty acids to your plants? It's like a whole, uh, I guess you could say like a whole prong of ingredients that is totally excluded from standard formulations. And even with the organic side of things, like most of the time, organics is going to be like a fish meal or a bone meal or a blood meal or alfalfa meal. No one is using fatty acids, not even in the organic side of things.
Yeah, everybody's looking at amino acids to synthesize that, but they can actually absorb fatty acids directly.
Yeah, and the important part there, and the reason that it works so well, is because cannabinoids themselves are kind of like
They're fat.
children molecules of two different pathways.
Yeah.
You definitely need uh, some polyketides to be present in addition to terpenes to be present, because the two, basically the polyketides and the terpenes, those two pathways both produce separate substrates or building blocks for cannabinoids. And then along comes cannabinoid synthase enzyme, maybe after olive acid becomes cyclized. Through olive acid cyclase is the name of the enzyme that does that conversion. There's CBGA synthase that comes in, and it makes CBG, which is the precursor for all cannabinoids. And it's the result of these two pathways that are separate, the polyketide pathway and the terpene pathway, coming together under the action of this CBGA synthase enzyme that synthesizes CBG, which is the very first like prototypical cannabinoid. And then from there, differentiation occurs. You have CBGA, becoming differentiated into THC or CBD, depending on the action of the enzymes that are associated with it. So there's a molecular fork in the road, so to speak, after that. But there's a convergent point. You have two separate pathways. They converge in the center point of CBGA synthase, enzymatic activity, and then from there it unfolds and opens back up. So you have multiple prongs in the road, molecular forks in the road. And what we're doing by feeding the cacao powder to the plants is stimulating the plant's ability to make more cannabinoids, because there's no bottleneck in the polyketide pathway, and that specifically happens as a result of feeding cacao to the plants. Like I said, it's very high in fats, very high in fatty acids. There are other phenolic compounds that can get repurposed and participate in the polyketide pathway. But yeah.
Very cool. That's awesome. It's so much stuff. I'm learning so much stuff just in this conversation. It's awesome.
Yeah, and one of the other cool things about root anchor, so like I mentioned, the hardest part of root anchor was stabilizing the cultures in there, because they're live and active. And the real question is, like, how do you get a live and active, blend of cultures inside of a bottle without it exploding?
Yeah.
That was really, really tough.
I Yeah, that's a real trick.
Yeah, it's real tough. The other thing that we used to do is we used to add beneficial mycorrhizal fungi. We would add glomus species inside of it, but we noticed over time, and after running the tests probably took like a year to year and a half for us to collect all the data, and we realized that the licorice root extract inside of root anchor is such a powerful fungal biostimulant that we actually didn't even need to add fungal colonies inside of that product. And so we eliminated all of the fungi inside of root anchor, and we noticed that people's natural biology, the fungal spores that are present in the air or in the soil, those just get upregulated. And typically within 24 to 48 hours after applying root anchor for the first time, it's not uncommon for us to see actual fruiting bodies pop up. So the mycelia are there, invisible, kind of working through the soil. You water in root anchor, and then 24 to 48 hours later, you actually have mushrooms that are popping up and growing out of the soil. We see it out of the bottom of the bags, out of the side of the bag. It's pretty impressive. And so we started thinking about that when we first started noticing it happen. And eventually it led to the conclusion that the licorice root really is a preferred food source for beneficial fungi. And they really, really, I mean, they go nuts over it. Their populations will just skyrocket and they'll multiply in the soil, which is really good for living soil chemistry.
Yeah, and also that kind of goes back to like if you're doing things right, you should theoretically have those in your soil already, and then if you can enhance their their growth and function, then
Mm-hmm.
then you're better off, right?
Absolutely. Yeah.
So last but not least, is the solar rain.
Yep. Solar Rain. That's our flagship product. It's a really, really good foliar spray. And the reason I say it's our flagship product is because it was the first product that we made where the benefits of our carbon-based approach were really evident. It kind of like the what Solar Rain did and what we saw it do, like the function that it achieved and what it was capable of um, doing for the plants, is something that inspired the rest of the product line to happen. We just saw like this was our very first, foray into understanding how carbon is metabolized by plants properly. Solar Rain was originally designed to be a magnesium-based foliar spray, and that magnesium specifically was meant to plug directly into chlorophyll biosynthesis, because oftentimes when growers are deficient in nitrogen or magnesium, the leaf surface will turn yellow, and then they'll do foliar sprays. Sometimes it's Epsom salt or something like that. And we really wanted to see a fast turnaround time between magnesium deficiencies and chlorophyll deficiencies and an upregulation of chlorophyll biosynthesis. So the idea was basically if you could get the plants to green up within a matter of minutes, that was a good sign. And that's certainly what Solar Rain does. It's one of the fastest working products I've ever seen.
Wow.
Your plants will definitely respond within 10 minutes. And I always challenge people. I say, find a plant that looks stressed out. Pick one that's maybe the runt of the litter, that's yellow, maybe not doing so well, and spray Solar Rain on it. And then come back in a couple of minutes and you'll see that the plant is starting to correct itself immediately within 5 to 10 minutes. It happens right away
Super
because
fast, man. That's incredible.
yeah, and it's like I said, the organic acids that we're utilizing and that we're manufacturing, from the plants that we work with in the fermentation chemistry, those are immediately recognized by plants and they're immediately taken up. So as soon as the foliar spray actually touches the exterior of the leaf, the nutrients start to get to work right away. There's no conversion, there's no nitrates inside of it. It's not magnesium nitrate, or there's no magnesium sulfate inside of Solar Rain. So there's no conversion, there's no breaking apart of the molecule, or no, funneling the sulfate down towards sulfate reduction where it can make thiol groups and become cysteine. And there's no concern about what to do with magnesium either, because it's in a form that the plants can readily take in and do something with immediately. And I think the reason that the response is so fast is because that particular fraction of magnesium can participate directly with whatever the chloroplasts are doing, where magnesium is present. It's pretty important for like ATP biosynthesis, and just the whole pool of free adenylate is set in equilibrium with the concentration of magnesium that's present as well. And then also in the mitochondria, because the mitochondria also are energy producing factories in the plants, and they require magnesium to function as well. And if you can stimulate both of these organelles within the plant cells, you can get a lot more energy being produced by the plants, a lot more energy being utilized properly by the plants. And so this foliar spray, when you spray it on the plants, it gets sunk into both the chloroplasts and mitochondria, which are active during the daylight hours. I mean, the mitochondria are active at nighttime. Chloroplasts are not active at nighttime at all because there's no sun, so they can't do electron transport in the absence of sun. There's probably some clever way to do it, but we won't get into that right now. But yeah, just doing a foliar spray of solar rain can make a big difference. The effects are pretty fast. They're apparent immediately, and the extent of those benefits can last anywhere from 48 to 72 hours. It's like the turbocharging effect that lasts for 2 or 3 days, and then the plants kind of burn through all the organic acids, they utilize them, and they get back to this equilibrium spot that, hopefully at that point you're ready to apply more solar rain to the plants, because they definitely like it for sure.
Yeah, well, but also you've also tuned that energy back up, and once the plant has more energy, it can just do so much more too. Like that's one of the things I've found with foliar feeds in general. Like if you have a plant that's struggling or has low energy, you can get that foliar feed tuned right, man. It's amazing how much just even one feed can change the dynamic of the whole season, even if you can't get back to it the rest of the season. So.
Oh yeah, a little bit can go a very long way for sure. Yeah, and there's something to be said about just all of these, particularly for young plants that have like really weak root systems, or maybe we're dealing with cuts off of a mom that don't even have established root systems yet. It's really important to do foliar sprays on those plants too. Unrooted cuttings are fantastic candidates for foliar sprays, particularly solar rain, because those organic acids are actually building blocks for new root material, and they're actually building blocks for auxins, which are rooting hormones.
That's awesome. I've done foliar feeds like a few days before I've taken cuttings, but I haven't had better than normal, but not great results. So I'm very much looking forward to trying this for taking cuttings. I think that'll help a lot.
Yeah.
The first few days can be tricky with a like you say, a cutting with no root system to support it.
Mm-hmm. Yeah, and the combination of solar rain and peak bloom works really well as a foliar spray on mother plants, maybe about 15 to 20 minutes before you take the cuts.
Awesome.
So you mix up the solar rain and peak bloom, spray the mom plants, wait about 15 minutes, and then take the cuts, because at that point, what gets absorbed inside of the cuts that you're taking is actually building blocks for new roots. And we see as close as reasonably possible, 100% success rate with rooting. And typically, if people are spending 10 to 14 days in that rooting stage, they could, get down to somewhere around 5 to 7 days at best. I mean, the fastest we've seen roots pop out is like somewhere between 3 and 5 days. It kind of, like every plant's a little different. Every cut's can be a little different. But I would say, if you're currently at 10 to 14 days to see the roots pop out, using solar rain on moms before you take the cuts will automatically eliminate, or not eliminate, it will reduce that significantly. So instead of 10 to 14, maybe you're going to be closer to 5 to 7 days, or 7 to 9 days, or something like that. But you can shave a few days off the overall rooting time, because you're loading those rooting precursors or substrates or building blocks for new root material into the cut when you take it. So as soon as you take the cut, there's this upregulation of enzymatic activity that yields, eventually after a couple of days, it'll produce more roots. And it'll produce them very, very vigorously too, because it has this pool of free energy to work with and to pull from. So there's no turnaround time, there's no shock or stress, especially not for the moms. They really like it. So it's a good advanced way to use that product.
Awesome. I'm looking forward to trying that as well. That's awesome. Well, that's the whole line of stuff that I have that we've run through. Do you have other products you want to talk about, or anything else you want to think about?
I don't think we sent you some primer A and B. Those are just the base nutrients that we make. And I think, because you've got really healthy soil chemistry already going on, I figured maybe just the additives would be better for you to try. But the primer A and B, those are like our answer or our equivalent for all the conventional salt-based programs that are out there. They're very popular. A lot of them are doing really well. A lot of these brands are doing very well, but they're all missing something. And so, like, the question for us was, how do we make a base nutrient that is compatible with the style and methodology that a lot of hydroponic growers like to employ, and still provide some of the benefits of our carbon-based approach? So it has to be stable in terms of its feed water, which a lot of the organic heavy product lines out there, they're not very stable. They'll quickly encourage, biofilm formation, microbial growth, things like that. That's not good in a deep water culture system. We're not good in a hydroponic type of a system. Not good for your irrigation lines either. Creating biofilm can clog emitters, and it's just a huge pain in the ass to try to get the emitters unclogged. So for us, what we wanted to do was make a balanced and bioavailable blend of all the macro and micronutrients in a two-part solution that could still deliver carbon and really just take the core philosophy that we have about our carbon-based approach to plant fertilizer and make the most out of that. Ironically enough, even though primer A and B are the base nutrients that are used more frequently than any other product, those took the longest to fully formulate, and those were the last two products that were actually like finally ready to go, because there was so much tweaking and so much tinkering going on, and we were trying to figure out how do we fit more carbon inside of the products and what's the most appropriate form factor for that carbon. Um, so we ended up with those two products. They work really, really well. The pH doesn't have to be adjusted. It does come out acidic for sure. If you're running an RO system, it's not uncommon for us to see a pH of about 4.0 coming out, which is really, really acidic. Most people wouldn't feed that to their plants, but I always say feed that to the plants. Don't adjust the pH. It's going to take a lot of pH up. I'll tell you that right now. It'll take a lot to adjust it up, and there's really not a benefit with it. The carbon that's present inside of primer A and B is in a sufficient quantity. It's high enough concentration, and it's the correct form factor to create a total buffered system of nutrient delivery. So even though the pH is 4.0, that's not going to burn the plants, and it's not going to cause any of the other elements to get locked out. Um, so yeah, it's very flexible. It fits in. It doesn't create any kind of biofilm, doesn't clog lines, very stable in the feed water reservoir itself. So if you're a salt-based grower and you're looking for more carbon, that's definitely a really good two-part solution to use. And it's got all the micronutrients inside of it as well.
Awesome. I might have to add some of that to my inventory as well, because that'll be nice for indoor stuff. It can be hard to like mix soils and make adjustments and keep things tuned and all. And that'd be a nice way to have a baseline to go off of, and something that works with this stuff as well, that I don't have to worry about, not your stuff, but their stuff, so to speak.
Yeah. And if you look at the NPK ratios on primer A and B, it's a good way to kind of line up some of the other base nutrients that are out there. Our guaranteed analysis combined between the two of them is 5.5% nitrogen, 3% phosphorus, and 10% potassium. So, and then 4.5% calcium and 1% magnesium. And if you look at those numbers compared to some of the other base nutrients, there's two things that stand out. Actually, three things that stand out. The first thing is that we're very high in potassium. I mean, 10% potassium is a pretty high concentration of potassium. But as I mentioned earlier, potassium participates directly with carbon metabolism in plants. And what we found was that if we wanted to feed more carbon to the plants, we needed to feed more potassium to the plants as well. That's why we ended up, as we, our focus was to try to, how do we get more carbon inside of the plants? And we kept ending up at the spot where the plants just needed more potassium. And we were at 300, 400, 500 ppms of potassium. We were just not capable of hitting the upper limit in terms of what they wanted. And it wasn't anything to do with the quantity of potassium that was being worked into the plant. It was everything to do with the quantity of carbon being worked into the plants. The more carbon you feed your plants, the more they take up, the more likely they are going to, be to need more or additional pools of potassium. The second thing that stands out is that we're pretty low in phosphorus, 3% phosphorus in the base nutrients, kind of low. I mean, I see 4, 5, 6, maybe 7% or more being present, and the use rates are higher than our primer A and B as well. But if you feed primer A and B in accordance with the feed charts that are on our website, you end up somewhere in that sweet spot of 30 to 50, maybe 50 to 70 ppms of elemental phosphorus. On the very, very high end, if you're feeding the heavy feed chart and you're using both Peak Bloom and primer A and B, you're getting somewhere around 90 to 100 ppms of elemental phosphorus, which is right there on the upper end of the sweet spot. It's not so much that you have to worry about problems happening in the soil chemistry with phosphorus and calcium not playing nice with each other, and you don't have to worry about plant deficiencies like not enough phosphorus. So it's that kind of the sweet spot just between the primer A and B and what they're capable of delivering, along with Peak Bloom as well. And then the third thing that stands out is the 4.5% concentration of calcium. That's pretty high. I have not seen. I think there's maybe like one or two other brands that are somewhere around 4 to 4.5%. But there's certainly very few, if any, at all out there that have more calcium in the base nutrient than we do. And when you factor in Calmag Fuel being 6% calcium guaranteed, that puts us way over the edge. So the full product line is extremely heavy in calcium and very heavy in potassium.
As it should be.
Yeah, as it should be. Yeah, calcium is very, very important. I feel like it's often overlooked in the industry, and a lot of the challenges that growers face on the day-to-day basis, particularly in the mid to late stages of bloom, those can be corrected with the appropriate amount of calcium being added to the plants.
For sure, for sure. Well, I'm looking forward to applying some of that to mine. I know I have some calcium and potassium deficiencies and some phosphorus deficiencies, so this is right up my alley for correcting those issues.
Nice, nice. Well, I'm looking forward to hearing what you have to say about the initial impression. How did the products work and how fast did they work, and was it really noticeable? We oftentimes get people that jokingly tell us it looks like we broke into their grow facility and like swapped the plants out, because they're like, there's no way that's the same plant. I mean, they just like yellow, scraggly, not doing so well. They spray solar rain on it, or they, whatever the deficiency is, they can correct it with using the appropriate product. And then 24 hours later, they walk in and they look at the plant. They're like, there's no way this is the same plant. It grows so much and so fast. There's nothing blocking its growth. There's nothing bottlenecking it anymore. And to say over the same 24-hour period of time, you may get 2 to 3x increase in productivity. Instead of just one new leaf set, you have 2 or 3 new leaf sets popping out. And then 48, 72 hours later, you look at that plant, you're like, 3 to 5 days ago, that thing was like barely alive, and now it's cranking away. It's going to be the biggest plant in the whole garden. It definitely happens. So yeah, I would be curious to hear your feedback and how apparent it is on the plants too.
Awesome. Well, I'll keep my eyes tuned, and I'll be taking pictures and video and all. So I will
Awesome.
definitely let you know, and I'll let our viewers know as well.
Cool. Appreciate it.
Well, thank you, Nick.
You got any other questions about the products before we wrap this up?
I don't think I do. I think I want to go out and play with what I've learned, and then I'm sure I'll have questions in the future. But
Cool.
for now, I think we're pretty well covered on it.
Awesome. Well, yeah, feel free to take pictures, send them over. If you got questions, let me know, and we'll check back in a couple of weeks, maybe mid-September. We can do maybe next end of next week, or maybe the beginning of that week of the 23rd. We can check back in and see how things are going. Love to hear the feedback and whatever else I could do to kind of help optimize things for you.
Awesome. Thank you so much. Thank you for sharing this with me and for sharing this information with us.
Absolutely.
I'm stoked, and I know my viewers will be too. So
Awesome.
really
I'm
appreciate
glad to be a part of it, man.
Yeah, awesome. Cool. Well, is there anything else you want to plug or say, or?
No, I mean, we have a lot of really good information on the website as far as feed charts go. We have a variety of feed charts, foliar spray charts up there. We like to give as much information about the products as possible. So the product pages, you'll see they're rich in information. There's a lot of good stuff on there. So if anybody has questions, feel free to reach out to me directly on Instagram. I'm usually the person that answers the messages. So if you guys, have a technical question or something like that, and you've looked at the website, please look at the website first. We tried really hard to put all of the correct information. We're not trying to hide stuff about what's in our products, and the guaranteed analysis is pretty close to what is reasonably going to be there inside of the products. It's always going to be a little bit higher, but the guarantee is what we can actually reasonably guarantee is going to be there at minimum. So take a look at the website. If you guys have questions, just feel free to reach out to me directly on Instagram, and I'd love to help answer questions or point you guys in the right direction for how to use our products and get the most out of them.
Awesome. Well, thank you very much. And I guess we'll end this live or this recording for now. And
Sounds good. Appreciate it.